talk about the refractory period. So this is a part of the EKG tracing and what happens when a stimulus is applied to the heart. So it says during the QT interval, beginning of the QRS to the end of the T wave is the QT interval. It takes less than 0.4 seconds, and it represents the general refractory period of the ventricles. So I need you to write down what refractory means. And it means not responding to an electrical stimulus. Refractory period means not responding to an electrical stimulus. All right, and so in other words, if there's a stimulus that comes either from the conduction, from the SA node to the AV node to the ventricles, if there's like an unusual arrhythmia, then nothing will happen. The ventricles will say, hey, I've just depolarized, I can't do that right now, and nothing will happen. Or if electrical shock is applied to the chest, the ventricles will say, hey, I just depolarized, I'm not doing anything right now. So it's refractory to a stimulus. But as repolarization progresses, some of the ventricular muscle fibers are repolarized. So the muscle fibers repolarize. And then at the peak of the T wave, you've got like half of the muscles have repolarized, the muscle cells, and half of them have not. This is a vulnerable period of time during which part of the heart can respond to an additional stimulus. A depolarizing stimulus during this time can create electrical chaos in the heart and render it functionless. You need a picture. Oh, I thought I had a picture on here. Let me just go forward and then I'll back up. Yes, I do, okay. All right, so the ventricles depolarize, and now the muscles can contract. And then after the muscles contract, now all the ions have to go back into their resting position. And so that's a refractory period. You can't give the ventricles another electrical stimulus at this point in time. But during the T wave, this is when the ventricles are repolarizing. So some of the cells have repolarized and some of them have not. At this point in time, if there's somehow an electrical stimulus given to the heart, it'll send the heart into ventricular fibrillation, and all of the ventricular muscle cells will just get very chaotic. You won't have the normal contraction of the heart. You'll have a quivering heart and no blood pressure, a cardiac arrest. So it's considered the relative refractory period. And the reason that period of time is dangerous is because an electrical stimulus can cause the heart to go into ventricular fibrillation. Want me to repeat it so you can write it down? So if there's an electrical stimulus during the second part of the T wave, electrical stimulus during the second part of the T wave, it can cause the heart to fibrillate. F-I-B-R-I-L-L-A-T-E, fibrillate. Which is cardiac arrest. All right, so on your exam, if you're asked, why is the relative refractory period of the EKG dangerous, what would you respond?
Because the extra electrical goes into chaos?
Yeah, so an electrical stimulus during that time will cause the heart to go into ventricular fibrillation. Okay, so now for the EKG, and looking at the graph paper, it says one small box equals, and then there's a blank for you to fill in, and the small box is 0.04 seconds. And when you add up 5 small boxes, that's equal to 0.2 seconds. So this is what the graph paper looks like as it's going through the machine. The machine will draw the tracing on the paper. You see little tiny boxes in a lighter pink color, and then bigger boxes in a darker pink. So one big box holds 5 little boxes. So 5 little boxes, they're 0.04 seconds per box. All right, when you're looking at an EKG, you're going to go through the same criteria each time you look at an EKG. And your first criteria will be to determine the rate, and there's a slide coming up for each one of these. After you determine the rate, you look to see if the complexes have regularity, meaning they're spaced evenly apart. Next, you look at the P waves and determine first if they're there and if they're normal. Then you'll measure the PR interval and see if it's 3 to 5 boxes. And then you'll look at the QRS complexes. All right, so as far as counting, there's different ways of counting the rhythms. And I'll teach it to you in the classroom, you'll have it on your exam. But when you're at the hospital, the EKG paper just prints the heart rate right on it. Or the monitor shows you what the heart rate is. So this is more for learning theory. The first way to assess heart rate is to count the number of QRS complexes in a 6-second strip, and then multiply by 10 to find out how much it is in a minute. Do we have a strip to look at? I guess that's the only one. All right, so this is a 6-second strip. And how do we know that? We could count all these boxes and see how many boxes there are. $15 and $15, so 30 big boxes is 6 seconds. So looking at 6 seconds, what is the heart rate?
60.
Yeah, so you just counted the number of, and you count the QRSs. And if there's 6 QRSs on the paper, you just multiply by 10, and now you know what the heart rate is per minute. The second way is to count the number of boxes between the R to R intervals. So remember, a QRS is called an R interval, or an R wave. So in between 2 R waves, you count the number of boxes. If you count the little boxes and divide the number into 1,500, it'll give you an accurate rate. Or if you count the large boxes, you can get a close estimate. So if there's only one big box between each R wave, you know just by a quick look that you've got a heart rate of 300 per minute. If you see 2 big boxes between the R waves, you know the heart rate is 150 per minute. So it's a good way of looking and getting a really quick estimate. 3 boxes is 100, 4 boxes 75, 5 boxes 60 per minute, and 6 boxes 50. You may end up having this memorized by the time the class ends, but if not, that's okay. So we have, let's look for an R wave that lands on a thick red line. Here's one right here. Let's count the number of big boxes between here and here. We've got 1, 2, 3, 4, almost 5. So 5 boxes, that means the heart rate's about 60 per minute.
So much easier than multiply.
We got to know all of these ways. The other way is we can find out how many small boxes and divide by 1,500. So you get out your calculator, 1,500, divide by, and then you count the little boxes. Well, each big one has 5. So 5, 10, 15, 20. about 24 little boxes. So it'd be 1,500 divided by 24, and that'll give you the rate. All right, so those 3 ways. All right, the next thing, and then it talks about a normal heart rate is between 60 and 100 per minute. So you would just make a comment like, the heart rate is 50 per minute, that's bradycardia, or it's greater than 100, that's tachycardia. And next thing you look at is the rhythm regular or irregular. So to do that, you have to measure the R to R intervals. So I can give you calipers. You have them in the drawer. And you can set the calipers between the first R to R wave, and then you just lift it off the paper, move it over, and check the next one, and the next one, and the next one. And if they're all the same space apart, then you say it's a regular rhythm. And you've got like a box and a half, still a regular rhythm. If not, you can just use a piece of paper and mark it with a pen. I'm giving you a handout in 1 second. Let me finish this. Okay, then you look at your P waves. Is there one before each QRS? And then is there a QRS after every P wave? So when I give you the handout, that's what we're going to do. We look at the PR interval. Is it 3 to 5 little boxes, or is it more? And then is the QRS complex normal? It's going to be 3 little boxes or less. Okay, so let me give you the handout, and that's what we'll work on. Actually, I want to go back. You want to turn off the video? Susie, is it okay if we turn off the video?
Silver button.
A silver button. I can do this.
Do it. We're rooting for you.